Hi everybody, welcome back to the Feynman technique. Today we'll be taking a look at this integral. This is just going to be kind of classic Feynman integration. We are going to be using a previously derived formula to solve this, but other than that, it's pretty much just basic Feynman integration. Alright, so what's our first step going to be? Well, this might be an unusual step, but we are going to let f of t be equal to this. And you can see, basically, I just replaced this, well, this square root of tangent x is just tangent to the 1/2 x, and I replaced that 1/2 with a t. Alright, so there's our f of t. So what are we going to do next? Well, obviously, f of 0 is going to equal 0. If we let this equal 0, we get tangent x to the 0, that's 1. 1 minus 1 is 0, so we get 0. And f evaluated at 1/2 is going to equal our target integral. Alright, so what next? Well, let's use the Leibniz rule for differentiation under the integral sign, which says that we can take the derivative of our f of t right here, with respect to t, just by taking the partial with respect to t of the integrand. So, taking the partial with respect to t of this integrand right here, don't forget we're treating everything that isn't a t as a constant. So when we take the derivative, the partial with respect to t of this, we just get this. So our f prime of t is this. All right, what next? We can let x equal arctangent of u. Of course, that means that u is equal to the tangent of x, so that means that this thing is going to just become a u. All right. And that also means that dx is 1 over u squared plus 1 du. So, our f prime of t becomes, let's see, our bounds of integration change. Because if x is pi over 2, then that would imply arctangent of infinity. So our u would become infinity. And of course, arctangent 0 is 0. And then we just get u to the t over u squared plus 1 du. And we have a formula for that. I will provide a link in the description to the video in which I proved this formula. But this is true. If this integral converges for whatever values of a and b, then it converges to this. All right, so from there, that implies that this is true. We just replace our a with a t and our b with a 2, and we end up with this. So that means that our f prime of t is just this. All right, but we are not interested in f prime of t. We want f of t so that we can plug in f of 1/2. All right, so what next? Well, we anti-differentiate both sides. Anti-differentiating f prime of t gives f of t, and this gives this. Okay, I'm not going to show this. It's u sub with the antiderivative of cosecant x. So, I mean, you don't watch this channel to see me do integrals like that, but it's equal to this. All right, now we can use the fact, that f of 0 is equal to 0 to show that c is equal to 0. So if we plug in 0 for t, we just get tangent 0, which is, of course, 0. And, well, what's secant 0? Well, that's 1 over cosine of 1. Cosine of 1 or I'm sorry, 1 over cosine of 0. 1 over cosine of 0 is 1. So c is equal to negative natural log of the absolute value of 0 minus 1. But the absolute value of 0 minus 1 is 1. Natural log 1 is 0, so c is equal to 0. So now we have this. F of t is just equal to this. All right, so now what do we have to do? We just have to plug in f of 1/2, and we have our answer. All right, so f of 1/2, well, if we plug in 1/2 for this, we plug in 1/2 for t, we get tangent pi over 4, which is, of course, 1. 1 right here. And if we plug in 1/2 for t here, we get secant of pi over 4, which is 1 over cosine of pi over 4. Cosine pi over 4 being square root of 2 over 2. So taking 1 over that, we just get the square root of 2. So that is the solution to our integral. We can go a little bit further with that. We can say that the absolute value of 1 minus square root of 2 is square root of 2 minus 1. And then we can use the properties of logarithms. You'll see right here, we have a negative natural log square root of 2 minus 1. We can write that as the natural log of 1 over square root of 2 minus 1. And then multiplying the top and the bottom by square root of 2 plus 1, we end up with this. So, in conclusion, the integral from 0 to pi over 2 of the square root of tangent x minus 1 over natural log of tangent x dx is equal to the natural log of square root of 2 plus 1. All right, guys, hope you enjoyed that, and we'll see you next time.